Hi all. Today we will be discussing the topics from basic computer organization and design, which is covered in the paper Computer Organization and Architecture. I am Niloofar, Assistant Professor, Department of Computer Science, ML College of Advanced Studies, Nilambur. Instruction codes. The organization of the computer is defined by its internal registers, the timing and control structure, and the set of instructions that it uses. A computer instruction is a binary code that specifies a sequence of micro operations for the computer. An instruction code is a group of bits that instructs the computer to perform a specific operation. The instruction code is usually divided into two parts. First is operation part and the address part. The operation part is a group of bits that defines such operations as addition, subtract, multiply, shift and complement. The address part contains registers or memory words where the address of the operand is found or the result is to be stored. Operation code. The operation code, or it is also called as opcode, of an instruction is a group of bits that define operations like add, subtract, multiply, shift, and complement. The number of bits required for the operation code of an instruction depends on the total number of operations available in the computer. That is n bits for 2 raised to n operations. The operation part of an instruction code specifies the operation to be performed. An operation code is sometimes called as macro operation because it specifies a set of micro operations. Stored program organization. The simplest way to organize computer is to have one processor register, accumulator and an instruction code format with two parts. The first part specifies the operation to be performed and the second specifies an address. The memory address tells the control where to find an operand in memory. This operand is read from the memory and used as the data to be operated on together with the data stored in the processor register. The instructions are stored in one section of the memory and data in the another section. The computers with a single processor register is known as accumulator AC. The operation is performed with the memory operand and the content of accumulator. For a memory unit with 4096 words, we need 12 bits to specify an address since 2 raised to 12 equal to 4096. 4 bits are available for opcode to specify 1 out of 16 possible operations. The control reads a 16-bit instruction from the program portion of the memory. It uses the 12-bit address part of the instruction to read a 16-bit operand from the data portion of the memory. It then executes the operation specified by the operation code or opcode. The operation is performed with the memory operand and the content of accumulator. Addressing mode. The operation field of an instruction specifies the operation to be performed. This operation will be executed on some data which is stored in computer registers or the main memory. The way any operand is selected during the program execution is depend on the addressing mode of the instruction. The purpose of using addressing modes is to give the programming versatility to the user and to reduce the number of bits in the addressing field of instruction. The following addressing modes are used for address portion of the instruction code. First is immediate mode. In this mode, the operand is specified in the instruction itself. An immediate mode instruction has an operand field rather than the address field. Next is direct addressing mode. In this mode, the effective address of the operand is present in instruction itself. A single memory reference is used to access the data and no additional calculations need to find the effective address of the operand. Here, effective address means the location where the operand is present. Next comes the indirect addressing mode. In this, the address field of instruction gives the address where the effective address is stored in the memory. This slows down the execution as this includes multiple memory lookups to find the operands. Effective address. It is the address of the operand in a computation type instruction or the target address in a branch type instruction. In this figure, the effective address in the instruction of direct address is 457 and the instruction of indirect address is 1350. So here comes the end of the section. I hope the concept we had discussed here is clear for you. Thank you.